Hi guys, so today we are going to be looking at factoring still. That's what this entire unit is based on, but we're going to start looking at it a little bit differently. So last week, if you remember, we did GCF, so we were just finding the largest number, largest variable that we could factor out, that we could take out of the entire polynomial expression. This week, we're going to start focusing on looking at factoring in a little bit of a different way. And the first way we're going to look at it is in the difference of two squares. Now, I don't know if you remember when we were in our exponents unit, when we were actually distributing and combining, I said like, oh, this is a difference of two squares. And I kind of was saying that to you guys a couple times to hopefully help you remember that phrase because it was going to be coming into effect now and I wanted you to still recognize it. Okay, so the difference of two squares, or what we're going to call it is dots. Some people just call it the difference of squares, which you'll see below. I always focus on the difference of two squares. Okay, but it is set up where you have two perfect squares. So you have a squared and b squared. Okay, a squared is a perfect square because it's a times a. B squared is a perfect square. It's b times b. If you have that, and if you have subtraction in the middle, because again, the difference means it's subtraction. So if you have two perfect squares, 1 and 2, and you have subtraction in between them, that's how they're being combined, then there is a simple way, there's a pattern you can follow for factoring it. And it's always going to look like a plus b times a minus b. So you take the square root of your first term, a squared, the square root of your second term, b squared, and you make one of them addition, one of them subtraction, and you would just multiply in between. Okay, so a squared is a times a, so the square root of a squared is a, so you would put a in both of those. The square root of b squared is b, you put b in both of the second spots. You just make one of them addition, one of them subtraction, and then you multiply in the middle, and that's how you would factor it. Okay, so let's get into some examples to see if we can figure this out. If it's not making sense yet, hopefully it will start to. So factor the following quadratic polynomials. Remember quadratic means x squared. Okay, that's what a quadratic formula, a quadratic equation is. If you notice in number 3, that's actually not a quadratic. We wanted to throw that in there. That's actually a quartic, but you'll see because we wanted you to kind of see what those problems look like. But starting with number 1, the first thing you always have to check to be able to do this. Remember, you need to have two perfect squares. So you look at x squared in number 1 and you look at 25. X squared and 25 are both perfect squares. The square root of x squared is x. The square root of 25 is 5. So then all you would have to do is just plug x and 5 into that formula. Since it's subtraction in here, you can just make it x plus 5 times x minus 5. That would be our answer. Now, how would you go about checking this? You remember we learned the FOIL method. So you can go ahead and FOIL this. X times x is x squared. X times negative 5 is minus 5x. 5 times x is plus 5x. 5 times negative 5 is minus 25. The negative 5x and the 5x would cancel out. You'd be left with x squared minus 25. So you know you did it right because you started with what you were given. Okay, so let's look at number 2. Again, first thing you need to make sure is that both of the numbers you have are perfect squares. X squared is a perfect square, the square root is x, and so is 4, the square root is 2. So you just plug it into that formula. We have x plus 2 times x minus 2. And it would not matter if you did x minus 2 times x plus 2 or vice versa. Okay? It doesn't matter if the addition comes first or the subtraction comes first in this case because it's multiplication at the end of the day. How would you go about checking this? FOIL. X times x is x squared. X times negative 2 minus 2x. 2 times x plus 2x. 2 times negative 2 minus 4. The negative 2x and the 2x cancel out, and you're left with x squared minus 4. So you know you did it right because you got what you started with. Now let's look at number 3. We know the square root of 16 is 4, so that's not an issue. But let's look at x to the 4th. We need to know if that's a perfect square. is there a number, in this case variable, that if I multiplied it by itself would give me x to the fourth? And there is. It would be x squared. Because if you did x squared times x squared, remember, a perfect square is the same number, in this case the same variable multiplied by itself. X squared times x squared gives me x to the fourth. So that would be a perfect square still. So then I would write out my formula. X squared plus 4 times x squared minus 4. This one just looks a little different because there's x squares involved. Okay? But I want you to notice something. I want you to look right here at x squared minus 4. If you notice, x squared is a perfect square. Square root's x. 4 is a perfect square. Square root's 2. We just saw this exact problem in number 2. So sometimes when you go to do dots, you can actually do dots a second time. So then the x squared plus 4 stays, and we'll talk about that actually in a couple problems, why that stays that way. But x squared minus 4 can be broken up again, and that can be broken up, which we already saw, into x plus 2 times x minus 2. And that would actually be our final answer. You need to fully factor it out. Okay, you would not want to leave it in that step above where I highlighted that x squared minus 4. You would want to make sure that you went ahead and factored every parenthesis fully. Okay, sometimes you can only do it once, sometimes you can do it twice. There might be a time where you can do it 3 times. It just depends on what you're given. Okay, but that would be our final answer for that problem. So let's go down here and let's look at number 4. Now we actually have a coefficient in front of the x squared, and that's okay as long as that coefficient is also a perfect square. So let's look. Is 49 a perfect square? The answer is yes. It's 7. We already know x squared, the square root is x. And then 64, the square root of that would be 8. So it's the same process. It's no different. It's just now we had a number in front. So now we would have 7x plus 8 and 7x minus 8. Okay, that would be our final answer. Now, how would you go and check? You would just FOIL 7x times 7x, 49x. 7x times negative 8, negative 56x. 8 times 7x plus 56x. 8 times negative 8, negative 64. The x's will cancel out. The negative 56 and the 56. You'd be left with 49. Sorry, that should be x squared minus 64. What you started with, so you know you did it right. Let's go ahead and let's look at number 5 now. Same thing here. 9 is a perfect square. Square root is 3. Square root of x squared is x. Because again, and this is just to make sure we're understanding this, 3x times 3x would give me 9x squared, which is what I want it to give me. Now what about 1? 1's a perfect square. The square root is just 1. 1 times 1 gives me 1. So I would write this out. 3x plus 1 times 3x minus 1. That would be my answer. Now, if you're not sure, you just FOIL 3x times 3x, 9x squared, 3x times negative 1 minus 3x, 1 times 3x plus 3x, 1 times negative 1 minus 1. Negative 3x and 3x cancel out. 9x squared minus 1 is what I'd be given. That's what I started with, so I know I did it correctly. Now let's go ahead and look at number 6, the last one here. You look at 50 and you look at 72. Neither one of those are perfect squares. So when you first look at it, you would say, oh, can't do anything with this. But if you remember from last week, we can always take out a GCF. So think, is there a number that goes into both of those terms that I'd be able to factor out? And the answer is you could factor out a 2. So if I factored out a 2, just took a GCF of 2 out, remember, I would then divide all of my terms by 2. So I would be left with 25x squared minus 36. Now, 25x squared and 36, those are perfect squares, right? 25x squared would be 5x. The square root of 36 would be 6. So now I can write, I would keep the 2 out front because I did factor that out. I don't want to lose that. 5x plus 6 times 5x minus 6. And if you had gone through and you distribute that 2 to the first set of parentheses and then FOIL, you would end up back with what you started with. Okay? So that is how we factor with dots. And that's only, as you can see, only works in very specific situations where there's subtraction, there are only two terms, and they are both perfect squares. If they're not, or if you can't factor GCF out to make it look like that, you won't be able to use dots. Okay? Now, earlier in number 3, we talked about why can't I simplify x squared plus 4. So let's look down here at a similar situation. X squared plus 36. They're both perfect squares, right? Square root of x squared is x, square root of 36 is 6. But it's addition here now. There's no subtraction. So some of you may say, well, what if I just did the same thing twice? X plus 6 times x plus 6. If you went ahead and FOILed that, x times x is x squared, x times 6 plus 6x, 6 times x plus 6x, 6 times 6 is plus 36. You would end up with x squared plus 12x plus 36. That's not the same with what we started with. So we know that that method won't work. If you tried to do the dots method, make one positive, one negative, you would end up with subtraction there. And that's not what we wanted either. So although you look at it and it looks like it should be factorable, you think that there should be a way that you can somehow factor that, you actually cannot. If it is two perfect squares and addition, you cannot do anything with it. It is actually as simplified as it can be. The only thing you could possibly do is take out a GCF if there was a number or a term that went into both of those. But other than that, that's as simplified as those ones can get, because there is no way to factor out an actual polynomial expression from there. Okay, so again, that was dots. Now we're going to look at our second way, and this is factoring by grouping. Okay, factoring by grouping. So in this case, you will have 4 terms. Above we had 2, now we're going to have 4. So the first step that we are going to do is group the terms. So when I say group the terms, I'm going to make the first 2 in a group with parentheses, the second 2 in a group with parentheses. And if you notice, I included that subtraction sign in the second set of parentheses. You want to make sure you are doing that. Step 2 then says factor a GCF out of each parenthesis. So I'm going to look at just x cubed plus x squared. Is there a GCF that I can factor out of that? So the largest term I can take out of there, the largest variable, is x squared. So if I took an x squared out of this first set of parentheses, I would be left with, remember, you do the division. X to the third divided by x squared would give me x. X squared divided by x squared would just give me 1. You want to include that 1. Then I'm going to do the same thing for this set of parentheses. Negative 4x minus 4. Here I can take out a negative 4. And if you remember last week, I said you don't always have to. This is a situation where you're definitely going to want to take out the negative, and you'll see why in a second. If I take the negative 4 out, I'm going to be left with negative 4x divided by negative 4 gives me x. Negative 4 divided by negative 4 gives me positive 1. Now, if you notice, the next step says to factor out the parentheses. I have x plus 1 and I have x plus 1. This is going to take a little bit of explaining, and some of you might catch on right away. If you notice, this is one whole term. This is one whole term. Okay, I have a common portion of each of those terms that I could factor out. If that's not making sense, it's no different than if I had 2x plus 2. There's a 2 in both of those that I can take out, just like there is an x plus 1 in both of these that I can take out. In this case over here, I would take a 2 out. I would be left with what's there, x plus 1. In this case, if I take the x plus 1 out, I would be left with x squared minus 4. And I think that's the hardest part to kind of wrap your mind around when we're doing these problems. These are 2 terms, and they both have x plus 1 being multiplied in them that I can factor out. If I factor out the x plus 1, I would be left with x squared minus 4. Okay, this video is about to end, so I'm going to pause it here and we'll continue on in the next video.